Team Meta, and we are a team of 4 members: Tuan Farm, Seema Rohila, Ravi Gupta, and myself, Bhushan. So today we'll be talking about AWS, that is Amazon Web Services. So as we know that most of the companies are moving to cloud infrastructure, and Amazon is one of the biggest provider of cloud services. So I'll be talking about few of the services, like giving overview of those services. So some of the services, as you can see here, are EC2 for computing. Then there is Lambda, which is serverless architecture. Then there are some storage services like S3, EFS, Glacier. They also provide databases as well as machine learning APIs. So it's a microservice platform which provides you with various services. So they are giving you AWS as infrastructure as a service, which has many microservices. So first of all, I'll talk about EC2. So EC2 is Amazon Elastic Compute Cloud. That is, it provides scalable computing capacity in Amazon Web Service Cloud. Using Amazon EC2, it eliminates your need to invest in hardware upfront so you can develop and deploy application faster. You can also use Amazon EC2 and launch as many as virtual servers as you need to launch. So it's a great facility that has been provided by Amazon. Some of the features of EC2 are virtual computing environments known as instance. Then it provides you with AMI. So there are various images of those instances. For example, if you're looking for some Linux instance, you can have Linux instance. For Ubuntu instance, you can have Ubuntu instance, as well as there are Amazon Linux and Windows instances available. So uh, then again, it has secure login, so they provide you with some PAM files, which hold the key for your. It is encrypted key, so you cannot disclose it on public domain. And using those key, you can log into your EC2 instance remotely. So it has this persistent storage volume called EBS, and it provides you the elastic block storage, and it uses elastic cache for caching mechanism internally. So those are some of the properties of EC2. It also has static IPv4 addresses for dynamic cloud computing. So if you have any project, for example, any Flask app or Django app, you can just put your code onto EC2 instance and run your server, and you can directly get that URL, and your site is up within a few seconds. So second thing I'll be talking about is S3, Amazon S3. So let's go to S3. So S3 stands for Simple Storage Services. It is a repository for internet data. As you can see here, I had created one bucket earlier in May. So Amazon S3 provides you access to reliable, fast, and inexpensive data storage infrastructure. It is designed to make web scale computing easy by enabling you to store and retrieve any amount of data at any time within Amazon EC2 or anywhere on web. There are many use cases for S3. For example, if you are doing some kind of analytics and you need to use some kind of database like Amazon Redshift, you can directly dump your data on S3, and then you can load that data into uh, your database. So it provides very easy access to analytics. The other main use case that S3 is used for is data pipelining. Most of people just dump their data from APIs to S3 buckets, so they can do the batch processing later and add those data, clean data into their databases. And even for real-time analytics, you can combine S3 with Kinesis, that is Kafka for Amazon Web Services. So with Kinesis, you can directly do your analytics on real-time data. So S3, Amazon EC2 uses S3 for storing Amazon machine learning images. You can use AMI for launching EC2 instances, as well as S3 is pretty easy to use. I mean, you just have to go here and create a new bucket, and you can store your data into that. And in order to access S3 from any program, you just have to download a library called Boto library, Boto 3. And with that, you need your Amazon ID, that is IAM access. If you go to your account, you can see that you have this IAM role created in Amazon. You can just give your credentials in that Boto3 library and you're set to go. You can upload your data to S3 programmatically. So that's all from me. Now Seema will talk about Elastic Block Storages.
The EC2 instance is backed up by the Elastic Block Store. So EBS provides EC2 with the block level storage volumes, and these are highly available and reliable storage volumes that can be attached to any running instance in the same availability zone. EBS volumes that are attached to an EC2 instance are exposed at the storage volume that persists independently from the life of the instance. So these EBS Amazon instances are recommended when you really want to quickly access your data, and also you want the long-term persistence for your data. And for data set like primary storage for file system databases, for any application that require fine granular updates and access to raw unformatted block level storage. So it's not like that, it doesn't it supports every kind of format, so you don't really have to format your data before storing. Amazon EBS is well suited to both the database style application that rely on random reads and writes, and to throughput intensive application that perform long continuous reads and writes. So in EBS, the data is also encrypted. So for simplified data encryption, you can launch your EBS volumes and is as encrypted volumes. Amazon EBS encryption offers you a simple encryption solution for your EBS volumes without the need of you to build, manage, and secure your own key management infrastructure. It is taken care by Amazon EC2 instances itself. And Amazon EBS encryption uses AWS key management service, which has like master key when creating encrypted volumes and any snapshot created from your encrypted volumes. So there are two things that are like main feature, or you can say things related to EBS. First is the Amazon EBS volumes. So Amazon EBS volume are actually your durable block level storage devices that you can attach to a single EC2 instance. So if you want more EBS block storage to your EC2 instance, you can attach these volumes. You can use EBS volumes as primary storage for data that require frequent updates, such as system drive, for instance, or storage for a database application. You can also use them for throughput intensive applications. And the major feature of these EBS volumes are that they are flexible. For current generation volumes attached to current generation instance type, you can dynamically increase the size. You can modify provisioned IOPS capacity, change the volume time on line production volumes. So they're very flexible when it comes to that. Another thing that are associated with EBS is EBS snapshots. You can back up the data on your EBS volumes to Amazon S3 by taking point-in-time snapshot. This provide you with like a backup system and provide you with a fault tolerance, introduces fault tolerance into your system. Snapshots are incremental backups, which means that only the blocks on the device that are changed after recent snapshots are saved. So there's whatever delta change is present, that only part is saved, and that actually helps you by not taking repetitive snapshots. This minimizes the time required to create the snapshot and saves on storage cost by not duplicating the data. So redundancy is removed. When you delete a snapshot, only the data unique to the snapshot is removed. Each snapshot contains all the information needed to restore your data to the new EBS volume. So here in this, we introduce fault tolerance. When you create an EBS volume based on a snapshot, the new volume begins as an exact replica of the original volume that can use to create the snapshot. So that's why we take point-in-time snapshots.
Once all your infrastructure and logging is set up, you might want to automate the management of these resources. CloudFormation can be used for this. CloudFormation is a service that allows resources to be declared in code, either with JSON or YAML. AWS provides an editor to declare these resources as diagrams. Once the CloudFormation templates are generated, a whole new stack can be created with the push of a button, pre-configured with the settings and files the application needs to run. Once you have your compute and storage infrastructure up and running, you might want to monitor your application. This is where CloudWatch comes in. CloudWatch provides logging and metrics to your application. To start sending logs to CloudWatch, just create a log group through the Management console. Once the log group is created, you can configure your EC2 instances to run the AWS log agent and push your application logs to the log group. CloudWatch also automatically records metrics like CPU utilization and network traffic for your EC2 instances. You can view this in the Metrics tab in the Management console. Metrics are divided into the AWS services like EC2 or S3. They are then further divided into groupings specific to each service, like autoscaling groups for EC2. From there, you can view all the available metrics for that service type. Some metrics have different dimensions and statistics. For example, ECS has the dimensions cluster name and service name, and CPU utilization has different statistics like min, max, and average. You can also place the metrics on a chart to see it as a function of time. Custom metrics can also be created via AWS's API. Another great feature that CloudWatch has is alarms. You can configure CloudWatch to alarm based on the metrics discussed earlier. The alarms can alert when a metric is below, at, or above a certain threshold. Autoscaling can be hooked to these alarms to dynamically scale in or scale out based on the metrics.